This is for those who believe in the potential of science, making brave choices, choosing to push the boundaries. This is why we believe in what science can do.
Great. It's super exciting to be here. My name is Carol, and I'm a computer scientist by training, but I'm a maker at heart. I want to share my world with you today. I've been working in robotics for about 15 years and was very fortunate to work in lots of different applications. So the future I see is where robots are touching virtually every aspect of our lives. It can start with entertainment, and they can amuse us. You can see robots helping us explore the depths of the seas and also in outer space. We can use robots to save lives through surgery and also disaster rescue. So I've been at Johns Hopkins getting my doctorate degree. And I didn't always know what I wanted to be. I didn't know anything about robots besides what I saw on TV when I was little. I was a kid who loved being very curious and adventurous and creative, and I didn't think engineering was for me. I didn't even know what it was. But I grew up in the Pacific Northwest. I came from Vancouver, Washington, and had all these stories about pioneers and the Oregon Trail and Lewis and Clark. And so I thought being an explorer was really interesting. But by the time that I grew up, probably the whole world would have been mapped, and there's nothing left to explore. I grew up in the 80s and 90s, and it was an interesting time because there was a new type of pioneer. There were these entrepreneurs who were creating this personal computer revolution. And there was a digital playground for me to go in. I could log in online and connect with people all over the world through a virtual chat room. And while the digital world really interested me because I could connect with people and talk to them and build a website for them to read or an app or find different ways to talk to them, I really wanted to live in the physical world. I wanted to be in the real world, to touch something tactile, to build things that I could see and play with. And robots were the perfect solution for that. What interests me about robots is that they help us explore places and go places that humans typically can't. I work on interactive systems that enhance our human capabilities to really make us superhuman. The area that I'm going to talk about is teleoperation. And teleoperation means that the human is in control, and we're controlling a robotic gripper, which could be right next to us or halfway across the world. And you can use it to scale down motion and be really precise and accurate, or you can scale up your motions and have superhuman strength and pick up a boulder or a rock. The next few scenes might be a little graphic. They got some surgical images, if that makes you uncomfortable. I really wanted to apply teleoperation in healthcare. And I really like being on the steep end of a learning curve, and I'm constantly throwing myself in these situations where you feel like you're just learning from all these people who are smarter than you. One thing I was advised was to never be the smartest person in the room. So you should always surround yourself with people you find extra inspiring or extra smart. So I didn't know anything about surgery, and it seemed really interesting. So traditionally, when you think about surgery, the image on the left is a sternotomy. So you might need to make a large incision. You might need to crack open the chest cavity to access the heart. And it's extremely traumatic for a patient. You have large recovery times, blood loss, and this huge scar, and it could take months to recover. The picture on the bottom was a new technology invented in the 80s, which is called minimally invasive surgery. So instead of making a large scar, now you're making these small incisions, about 5 to 8 millimeters, and you're inserting a camera and your instruments in through these holes. And it's improved the quality of life for a patient because you can be up and coming and walking around in days as opposed to months of recovery time. And you have smaller scars. And while it's great for a patient, it requires an extremely high level of skill for a surgeon. They have to do extra fellowships to learn how to use minimally invasive tools. This is a surgeon who is doing minimally invasive surgery, and you can see some of the drawbacks. So one is that they're inserting chopstick-like instruments through these ports. And there's a broken hand-eye coordination. So if that seems familiar, it's basically where your hands are doing something and you're looking at a 2D screen somewhere else. So something that I like to tell kids is that if you play video games, it helps you become a greater surgeon. So if you ever need an excuse, there's one for you. The other drawbacks from minimally invasive surgery is that it doesn't have any tactile feedback, and you don't have any wrist. So you're having to operate really stiffly, and you can't, as a surgeon, feel any of the textures that you would. So you don't know how hard you're pulling on that suture when you're tightening. You don't know what you're exactly gripping, and you have a really shaky hand. So I'm going to show a quick video just to demonstrate how a robot might be able to help in this situation. So like you saw, this is a standard procedure here on a patient. If you guys remember the game Operation, it was popular while I was growing up. It required a skill and concentration to keep your hands steady, and if you hit the edges, your patient will buzz. So, and it could be an extremely frustrating experience. So if there's only some way to engineer a solution, and as an engineer, you're problem solvers. So this is the Vinci robot. It's made by Intuitive Surgical. It's a commercial system that's been available and in hospitals worldwide. It is a minimally invasive device where you would stick in the camera and these two arms that you see here. A surgeon would sit at the master console and be able to manipulate the robot through teleoperation. So it's separated, the surgeon and the patient is separated by a 30-foot tether. Some benefits of the robot is that you do have these wristed motions, and they translate to your wrist, so it's very easy to learn how to use. You also have 3D vision instead of the 2D screen, so you're able to see depth. And it also gets rid of hand tremor reduction. So if you stick out your hand, you'll notice the human shakiness. There's a filter that runs through to make your motions extra smooth, and you can also be extra precise to have 3-to-1 scaling or 5-to-1 scaling. So it makes difficult tasks a little bit easier. So this video was done late in lab one night with a few of my coworkers and I, and we submitted it to the Robot Film Festival and won the People's Choice Award in 2011. Thanks. So how I imagine technology shaping surgery and in the operating room is that the first step might be to create extra awareness, so senses that we as humans don't have. One way is through augmented reality, which means that you just superimpose graphics or maybe sound, forces, smells, different types of senses to gain extra information that we might not have with the limitations of our human body. Another thing that Intuitive Surgical, who makes that Da Vinci robot that you saw, also has a mode called the Firefly. So you can inject a dye into the human body, and that shows up green with infrared light. So you're able to see kind of X-ray vision or enhanced vision that you wouldn't as a normal human. Mistakes also occur in the operating room because surgeons are extremely busy and their cognitive workload is pretty high. So one mistake is that they might accidentally leave an instrument or a cotton swab inside your body. So if you can use technology to track your instruments, mistakes like that won't happen. And the future of surgery that I see is where incisions and scarring gets less and less, so it becomes less invasive. One day I imagine if you can use snake-like robots, you can enter in through natural orifices like your mouth, and you can walk out of an operation without any scars. There's also pill cams that you can swallow that has a camera that can possibly diagnose or prevent and catch diseases before they happen. Outside of the operating room, there could be intelligent robotic assistants. So robots can be used as human companions. I imagine that they might be used for the elderly. They can remind you to take your pills. They can help you go through exercises every day and work out with you. There could be nurse bots. There might be opportunities also for a teledoctor to beam in and chat with you so that you're not limited to your local area. You can get the best expertise anywhere in the world. Since I work in teleoperation, an area of interest is definitely how far can you perform a surgery. So in 2001, this proof of concept surgery was done where the surgeon was in New York and the patient was in Paris. And it was the first transatlantic surgery. And it was performed successfully. It was a gallbladder surgery. And so it really opens up the imagination for the opportunities for underdeveloped worlds, or if there's a disaster, where doctors, you can deploy low-cost robots in a disaster area, and doctors from all around the world can beam in and help disaster relief and get them at minute zero. So while I was working on this in grad school, it's immensely rewarding and exciting. The robot that I showed you cost $2 million for all the bells and whistles. And I started to wonder, how do you build technology that can impact lives but not at as heavy of a cost? And not everywhere in the world can afford these $2 million robots. So I started getting interested in low cost and the maker movement. So I really wanted to enable people to learn about technology and empower them to build things. I think the next generation should be a generation of makers and not just consumers of technology. So Make Magazine is an amazing publication that teaches, that goes through state-of-the-art stuff and what robotic hobbyists can build. And it does step-by-step instructions for low-cost projects. So I'm just going to go through a few of the projects that we've worked on. So another nifty 50 speaker and I, Bobby Omriger, did a hack for the game Guitar Hero, if you guys play that. His job is to design the next revolution prosthetic arm for DARPA. And we had a picture of that here. And he had found that there are senses on your forearm that map directly to your fingers. And so for amputees, if they don't have the fingers, they can still flex their muscles, and it would map onto where the fingers would be. So for Make Magazine, we did a low-cost tutorial on how do you build a hack to Guitar Hero if you as a human want to just flex your fingers and not need a physical guitar. So we've got step-by-step instructions in volume 29 that allows you to play Guitar Hero. Also, I was interested in healthcare for third world countries. So it seemed like high blood pressure was the leading cause of death for pregnant women in these third world countries. And the easiest way to detect that is through like a blood pressure monitor. Down there, there's not trained personnel, so we wanted to create an automated solution, and we did a do-it-yourself tutorial hack, and I did this with some of my lab mates. And then I started getting really creative, and I started having fun with all this technology, and wondering if we could build robots that make art. Can we make beautiful design out of 3D printed material? And I even designed my wedding band and printed it out of silver. But all that was prototyped with the MakerBot. And while all this was really fun, I started realizing the need to reach this younger generation and to teach people how to get into building robots at a younger age. And I really wish I had started even earlier than I did. My first coding class was in college, and I had gotten thrown into this class with all these boys that had programmed since they were like 10. So it was a steep learning curve for me. And started helping out with FIRST robotics, and then designed a medically focused one at Johns Hopkins. And it's in its 7th year right now. The idea behind it was to find a grape which was embedded in Jell-O, which is actually supposed to simulate a tumor inside of a patient. And you guys would use Lego Mindstorms and detect where that tumor was and insert a needle at the appropriate depth and extract it out. So it was really interesting, and it's really rewarding to see these hundreds of kids around the Baltimore, DC area that can participate, and it's still going on every year. However, I still really wanted to reach more and more people, so I started, for the last few years, started interviewing and like observing all these kids and going into classrooms. And like any scientist, we write up what we find. So after talking to kids, I started realizing that there was a perception problem with robots. So robots have a really bad PR problem. So I think the media tells stories, and science fiction tells stories about robots that are going to take over the world. There's going to be robot overlords. Robots are going to go berserk. And I think that's really unhealthy for people to have fear of technology. I think the Japanese culture has a really interesting way where they really embrace technology and play with it and get really creative. And I think that robots need to be viewed more as a positive light in ways that humans and robots could collaborate. A lot of the kids also thought that robots were awkward and weird, and they didn't want to build one because it was made out of metal. So in research labs around the world today, they've been researching different types of materials. So if robots want to move out of the labs and out of the factories and into our lives and into our homes, they're going to have to be made from different materials, like silicone, like pneumatic air balloon robots, so that they're safe when humans interact with them. The one on the bottom is a gripper that's made out of coffee grinds, and when they suck the air out, it's got a really strong grip. So it's been really innovative and creative what these researchers are finding in the labs. The second thing I learned from kids was that engineering's a guy thing. And while the population of the world, women make up 50% of it, which means out of 10 people, 5 are girls. In engineering, 1 out of 10 are female. So it's incredibly imbalanced. And it's a huge problem because if the next generation is going to design for the future, we need to have a female perspective and to have females also help design. So what was bothering to me was besides this ratio, was that when I started asking kids why they thought this was, there was a difference in answer around between the second and third grade. And in third grade, some of the guys and some of the kids are tremendously honest, and that's what I love about hearing their answers. But they started to think that perhaps it was because guys are smarter than girls, and that it was a dirty job, and girls didn't want to do it. And I started realizing that that's not true. It's definitely not an intelligence thing, because girls have higher GPAs through high school in math and science. Yeah. And I think it's more of a confidence issue, and this lack of role models. They don't see women out there. If there's only 1 in 10, there's not very many of them. My personal role model is Ada Lovelace. In the 1800s, she's actually credited to be the first computer programmer ever. And she wrote the first algorithms. And she had this fascination with how do you get machines to actually think? And this is before calculators. This is before the internet, before iPhones. And so she really wrote the first computer program. And what was interesting about her is that she kind of merged math and science, and then on the other half, she really loved humanities. Her dad was a famous poet, and so while she was writing programs, she called it really poetic coding, and once you have mastery of a language and you can talk to machines, it gets to be really fun and very creative. The third thing I learned about kids was that they thought that you had to be a super genius in order to build a robot, and that's really not true. I think sometimes you see these lone geniuses or evil mad scientists, but I think every project that I've showed you, I've worked with a large group of people, and we're all trying to solve the same problem. And there's a lot of different solutions, and a lot of times we got stuff wrong. So I think this whole super genius idea definitely needs to be shattered and is not true. The next thing I found was that if I was to give kids the project of building robots, they actually didn't know how to start. It was basically, if they were to list out the steps, it would basically be like, buy random materials, build robot. And then there was, I think, a lack of understanding the design process or how to think through a problem. So taking all that, I started to think about what I could do to help design something that might be able to walk them through all this and tell a really fun, creative story, and show the softer side of robotics, this lovable, fun side, and how humans and robots could collaborate and work together to kind of have these superhuman, supernatural powers. So you can meet Ada Beta, inspired by Ada Lovelace, of course. And it's about a girl who invents and builds a robot. And she's not a super genius. she's a regular girl, and her and her friends kind of go through the world of programming and 3D printing and making and becoming these robot doctors while they need to troubleshoot and fix their robot patient. And so I'm currently writing the book right now, and it's been a lot of fun. So I think this next generation of children need to have a fun relationship with technology and really not fear it, but really embrace it. And not just build things, but also take things apart once in a while, blow things up. And I think that's extremely fun and healthy in a way to figure out what works and what doesn't. While I was growing up, you can't plan for things. I think you guys have heard a lot of talks today about people whose paths get detoured through life. And the job that I have now didn't exist when I was a kid. And I'm sure that the jobs that you guys want in the future probably doesn't exist if it's cool enough. So you can either make your own job or just learn a huge variety of skills and pursue whatever you want and kind of merge it and make it. And if you pair that up with technology, I'm sure something cool can come out of it because you can make and do anything at scale with technology. So thank you very much, and hopefully together we can save the world one robot at a time.